Hi everyone, today we're going to be looking at two-step experiments and how we can represent these using a table, right? Because a table is just going to give us a visual way of seeing it. Now, when we have a two-step experiment that we can display as a table, we're assuming these are two independent steps, right? And so I might have, like this example here, a spinner with the numbers 1 to 4, and that's going to be my event 1, okay? So I'm spinning this spinner and then I'm choosing a card at random from this pile here. And that's going to be my event 2, right? And so let's say that we have spun the number 1 and we've picked out the letter the letter P. The way that we're going to write this is 1P, right? And then we're assuming, okay, I've picked out the number 1 and I've picked out the letter I. So that's going to be 1I and then 1E. And we can go through a table like this just to list all our possible outcomes, okay? And so we're assuming that the number is going to get picked first, but also if they're two independent steps, it doesn't actually matter if I spin the wheel and then pick the letter or if I pick the letter and then spin the wheel, okay? But we've got our total sample space here. So looking at this table, how many outcomes do we have? Well, it's going to be the 4 times 3. So we have 12 outcomes. If, let's say, event 1 had 5 outcomes and event 2 had 7, then it would be 35 outcomes. So that means if we're calculating probability that the total number of outcomes is going to be out of 12, right? So the combination of 3P, well, there's only one of those in that box, right? And so the probability is going to be just 1 out of 12, okay? And now an even number being chosen together with a vowel, well, our even numbers are 2 and 4, so we can forget about 1 and 3. And then our vowels are I and E. Okay, so we've got, we're going to say even plus vowel, and that's going to be 4 out of the 12, which if we simplify that down will be 1/3. So we can count out our probability from our table. Now feel free to pause and give this one a go by yourself, but I'll go through this as well. Now our spinner here, 1 to 3, that's our event 1, and I'm going to place that across the top here. Okay, because once again, the order of the events, if they are independent from each other, doesn't actually matter, right? And then down the column, we're going to have A, T, H, S from those letters. So inside our table, we should have A1, A2, A3, and so on. T1, T2, T3, H1, H2, and H3, and then S1, S2, and S3. So how many outcomes does this experiment have? It is once again our 4 times 3, so we have 12 outcomes. Now the probability of having just 2S, well, that's the same as S2, right? So that's going to be 1 out of our 12 possible outcomes. And then the probability of an odd number being spun and a consonant. So for those of you who aren't quite sure what that means, it just means not a vowel, right? But an odd number and a consonant. So we can ignore A, and then we're just looking for the consonants that come with an odd number. So we've got T1, H1, S1, T3, H3, S3. Okay, and we can write this out as odd consonant, right? And now we have 6 options that we've highlighted there out of the original 12. And so our probability of having an odd with a consonant is going to be 1/2.